So we're going to focus on the graph of an ellipse here, section 13.2. Now, just a little bit of vocabulary for you so that you can nail one of the easy questions in WebAssign. The major axis is the longer of the two axes. The minor axis is the shorter one. So the major axis goes between these two vertices, would be the fancy vocabulary word that fills in this sentence up here. V1 and V2 are vertices. But the way I see it, there's two other vertices here as well. There's one here and one here at either end of the minor axis. So there's a total of 4 vertices. Now, graphing the vertices is probably the easiest way to graph your ellipse. So let's do the example down here. And just gotta copy that over to this right here. 64x squared plus 9y squared equals 576. What I would do first is I would divide everything through by the number on the right-hand side. And the reason for that is it's going to give me a 1 on the right-hand side, which I need to put it in the so-called general form and make it easier for me to graph. So if I divide everything by 576, then I end up with x squared over 9. 9 goes in there 64 times. And a 1 on the right-hand side. Okay, that's not too bad. You might benefit from doing one more thing to that, and that is writing it as x squared over 3 squared plus y squared over 8 squared equals 1. And the reason for that is because this is now in the perfect shape of an ellipse, and you can tell a few things about this ellipse. You can tell the distance from the center to the vertices in the x direction. You can tell the distance from the center to the vertices in the y direction. So let's graph this. How far, excuse me, let me start this way. What's the center of this ellipse? What's the center? Does anyone know? Courtney, think back to our work on circles and look at these square terms. What would the center be?
H and K are 0.
Yeah, they're both 0. So 0, 0 is the center of this ellipse. Now, the nice thing about having it in this form is that it tells you basically where to go to find the vertices of your ellipse. I'm going to go 1, 2, 3 spots to the right, and 1, 2, 3 spots to the left. And those are 2 of my vertices. That's for the minor axis. You might notice that I drew this taller than I did wide. 2, 3, 4, 5, 6, 7, 8. Way up here, it's going to be one of your vertices. And then down below is going to be another one. These are the 4 points that you'd use to draw your ellipse. So let me see if I can do something less than an embarrassing job of graphing this. And let's see. Now, the good news for you is you're not going to have to graph this kind of by hand in class because we're not in class. But if you were in class, I would ask that you take great care in not drawing points here. These are nice smooth vertices, or the graph passes through there in a nice smooth way. But that's it. And it's really nice that you can get those points quite easily just by looking at the form of the equation. You don't really have to go any deeper than that. So are we good with that first example? Example A. Now, there are a couple of problems that do ask you to do some graphing, and they're very specific. Let me show you what they look like in WebAssign. And let's see, there's a question here first. Let's see. So let's go to this one. Just find 2 points on the graph of x squared over 16 plus y squared over 4 equals 1. So, okay. Let's see if we can do that. Now they tell us to start by letting x equal 2 in these equations, and then moving from there, try and find a couple of values for y. So it would look like this. X squared over 16 plus y squared over 4 equals 1. We're going to start out by setting x equal to 2. So that's going to be 2 squared over 16 plus y squared over 4 equals 1. 2 squared is 4. 4 divided by 16 is 1/4. Okay, we still have a long ways to go to solve for y. And my guess is that a lot of you are really not happy about the fact that we've got fractions here. So how about if we get rid of the fractions? What could I do to get rid of the fractions in this equation?
Multiply both sides by 4.
Awesome. Thank you, Abby. Multiply both sides by 4. So when I do that, let's bring that work up here. 4 times 1/4 is going to give me a 1. 4 times y squared over 4 is just going to give me a y squared. And then equals 4. Now we just went through chapter 10 a little while ago, so this hopefully is a little bit fresh. If I subtract 1 from both sides, I get y squared equals 3. What would y equal?
The square root of 3?
Good, square root of 3. Someone want to add a little bit more to that to make that a complete answer?
Plus or minus.
Plus or minus.
Yeah, we need that plus or minus. Now, kind of a clue that you need that plus or minus is the fact that they're looking for 2 solutions. All right, they're looking for one with a smaller y value and one with a larger y value. So let's see here. Both of these have x equal 2 as their x coordinate. And then the y coordinate, they want you to list it as a smaller value and the larger value. I hate that. I've complained to the reps about it. I don't like it. I think they're going to do something about it. But you shouldn't have to be that careful in writing things. Unfortunately, you do. There's your answer. There's your 2 answers, 2 and negative root 3 and 2 and positive root 3. But please be careful in the order you plug those in, because it will make a difference. They just haven't coded it that way. How are we looking on this one? That one okay there? That example? Let's take a look at things this way for our visual learners here. Let's see. You know, I thought I had this one. Yeah, here it is. So here's the graph of that ellipse. And let's see, let me. There we go. That looks a little bit better. So there's the graph of that ellipse. And here's our 2 points, right? Over here on the left-hand side, there's 2 and negative root 3 and 2 and positive root 3. So those 2 points fall directly on that ellipse, which is good. They should. What else we got for you here? Which conic am I? I did send out a little email about this with an attachment. I'm thinking that this little diagram might be overkill. It really refers to the attachment that I sent on my email, where you have conic sections written out like this. One clue to look for when you're trying to decide what conic section you've got. That is, do you have a parabola, hyperbola, circle, or ellipse? One clue you can look for is whether or not your squared term, whether or not there's two squared terms in your equation. If there's only one squared term, it has to be a parabola. There's just no choice about it. If you got one squared term in a graph, it's a parabola. If you got two squared terms like this, especially when you have one on the right-hand side like this, that's your ellipse. And finally, if you get something like this, where you've got a nice term on the right-hand side, not necessarily one, and then this stuff on the left-hand side, that's going to be a circle. I think that's probably the easiest way to look through these things, is look for things in these forms. That's the form of an ellipse. Only one squared term, that's going to be a parabola. This one's a circle. Now, we'll finish up by reverse engineering this one. So if you're given a graph like this and asked to figure out, well, what's the equation of this, then start with this point right here. What's special about that point?
It's the center.
It's the center. Great. And Grace, can you tell me the coordinates of the center?
-1, 3.
Good. -1 and 3. Now, as far as our equation goes, that gives us kind of a nice head start. That's an H and that's a K. We're going to put that into that general form, x minus h squared over a squared plus y minus k squared over b squared equals 1. That's your h and k, so you're halfway done. So x minus -1 squared, and then y minus 3 squared equals 1. We've just got to determine a couple denominators next. So what would those be? Well, let's look at the distance from the center to the vertex in the x direction. How far between these 2 points? Between this one and this one on the edge of the ellipse. Can anyone
5?
count that out? Yeah, I get 5, right?
Yeah.
So if you start here in the center, 1 puts you on the x-axis, and then another 4 more takes you over to the edge of the circle, or edge of the ellipse. So it'd be a 5 here, but it's not just a 5. What else do I need to put here?
Squared.
Squared. Excellent. Let's do the same game in the y direction. This time from the center, you got to move a distance up 4 to get to one of the vertices, or down 4. Either way works. So down 4, up 4. But that distance again is 4. So like this. Now, if this was a test, I'd be very, very fine with that. I do have a small preference for you writing that as x plus 1 squared over 5 squared plus y minus 3 squared over 4 squared equals 1. I don't think WebAssign would mark you wrong if you handed it in like this. I'm sure that they would let that go. So how's that one looking? Doing okay there?
Yep.
All righty. I think that's about all I need to cover from this section. Is there anything else here? No, that should do it. All right, so we'll stop things here. If you have some questions, reach out to me. If not, then cool.